Hello, everybody. Thank you for joining my session today. My name is Brian Bockold. I'm with Coalesce Solutions, and I'm going to be going over migration migraines, common pitfalls to avoid when migrating your ColdFusion stack to AWS. Thank you for joining today. So let's jump right in. So in this session, we're going to review some migration options that you will go through when you choose to migrate to the cloud. We're going to go over some high-level problem resolution topics. We're going to introduce some AWS services so that everybody has a clear understanding of the tools that I may use along the way. And throughout all of this, recommendations for how to best approach some of these choices. Before we begin, real quick, a little bit about us. So Coalesce, we've been working with ColdFusion for many years now. We have a history of success in the high compliance realm, whether that's Gov Cloud or commercial. We are certified in AWS, multiple AWS certifications. We have our certified professional Adobe certificates as well. And we are proud to be a hosting partner, solution, and development partner with the Adobe ColdFusion team. All right, so, sorry. This is a screen where we discuss, we work with our customers to reduce the pitfalls. And we've been doing this since 2014 of migrating our customer environments from their on-premise to the cloud. And after all these many years, we are proud to offer these services to our customers to help mitigate migraines. And this infrastructure services of building, managed services of maintaining, and professional services of customizing. And perspective of the various AWS icons that we've come across and utilized in the past. And there's many more around this, and we're actually adding on more quite often every week, it seems. So there's a lot to go over, and we're going to focus on migration in this perspective. So we'll kind of keep this minimized as much as possible. So we're going to start with the migration paths. So when you decide to move to the cloud, you're going to have these decisions that you have to focus on. And I'm just going to run down these very quickly. You're going to either decide to move from your on-premise to the cloud. You've got two options with that. You're going to rehost your physical infrastructure to cloud infrastructure. If you're using VMware, you're going to relocate your VM hypervisor images from your on-premise or wherever it is to the cloud. If you're going to move to managed services, you're going to re-platform. So for example, you're used to running your MySQL database on your own server. You can now offload that to AWS. So you're no longer having to manage patching servers, dealing with mirroring, backups, so on and so forth. Another option here is repurchase. So if you have a product you manage yourself, you can acquire a SaaS subscription through AWS, and you can migrate your data to that. And then last but not least, refactor. This is where it gets interesting. You can change your development, your code, utilizing the SDK provided to utilize cloud native application services such as DynamoDB, S3, SNS, SQS, so on and so forth. A bunch of three-letter abbreviations, very endless. So these are very high level, the migration paths you would go through. All right, so before we begin, I'm going to introduce two different tools AWS has. In this case, we've got the database migration service and the schema conversion tool. The database migration service is the tool that you use to actually move data from your existing server to a running instance in the cloud. And the database migration service not only moves the data, it can convert from one form to another. For example, Oracle to MySQL, Oracle to SQL Server. And so it's a very critical tool in how you would make this migration be a success. The schema conversion tool is a tool you can use to actually move the skeleton of your database. So if you are moving from Oracle to MySQL, you'll use the schema conversion tool to read the source structure and write to your new database the equivalent structure in whatever engine it's running. This will include your database structure, your foreign keys, triggers, store procedures, so on and so forth. It's all done by these two tools. Now, the database migration service will create your skeleton structure for you, but you're going to find it's missing much of the programming level and heavy linking that is done by the schema conversion tool. All right, so starting with the database. When you are migrating your database, you need to keep an eye out for a few things. Those would be foreign keys, triggers, and your large objects. So if you are migrating data live with database migration service, which so if you insert a record in your local on-premise server and it gets replicated to your cloud server, the same actions that are, or restrictions that are applied to the cloud. And if they come in a different order, for example, one table's dependent on this, if they come in the wrong order, your foreign key would be triggered and it would not allow that insert to happen. That can cause you some headaches if you're not running in the proper order, or if you have a very complex web of requirements of your database tables. Triggers, I'm sure you can imagine the same situation with triggers. If you're inserting a record and by that record, it's doing a number of other database actions, you can imagine this is going to cause a nightmare of data corruption probably along the way. And that's because not only is your primary data table being migrated, any other data tables that are being impacted by the triggers are also being migrated, and it can have a last in this list, by default, the database service doesn't, it limits the size of large objects that are migrated. So if you are storing, for example, a megabyte of data in a field, but your migration is only set to do up to 32 kilobytes of data, your data is about to be truncated for every single record in the table. So on those things, you know your database is best and work out how to make that migration work. So what I recommend in this circumstance for the foreign keys and triggers, especially in your destination database, be sure to disable those before you go live. You can re-enable them, but during the migration, turn them off. Otherwise, you'll be spending forever issues. For minimal or no downtime in your migration, you can consider pointing your database migration service to migrate to your to-be production server. Like for example, in this flow chart right here, you're using EMS to point to a staging server, which is then recovered to a production server that ends up being your final product. If you must have no downtime, you can actually point your database migration service to the production, and you could reseed your auto increment fields. So let's say that you insert on average 10,000 records a day, you could reseed it by 1 million. And as you swap from your old server to your on-premise to the new one in the cloud, records can still come drifting in from your on-premise. So you give yourself that 1 million record leniency for maybe a customer still using the old DNS entry and they still use it for an hour after everybody else does. You don't have to have a hard cutoff for this turnover time period. Just an example. Now, one more thing on the database, the last bullet point, we're talking about the database engine. So if you're moving from MySQL to MySQL, SQL Server, then instead of using the database migration service to move all of your old data, the recommendation is use a backup to do the first large scale move. and then use database migration service to do from that point on. So once you configure your database migration rules, it can keep your on-premise server and your cloud server within, depending on your network latency, probably within milliseconds of each other in terms of the database records being up to date. So before I go into the next one, I'm going to introduce the DNS portion of AWS. So the managed DNS service that Amazon has is called Route 53. And if you use Route 53, you get some extra options that you may not be available to you if you use a third-party DNS provider. In this case, it gets to be more important as I run through this. So usually if you launch a server with a company, you get an IP address, and that's how you refer to that server. For a majority, if not all of AWS services, the way you refer to those endpoints that are created are through DNS values. So you'll get a unique name for your service in a DNS entry, and behind the scenes, AWS is managing the IP addresses utilized by that DNS, and it may swap them as necessary as services are disconnected or reconnected or expanded. And with that, instead of using an A record in DNS, you'll use CNAME to point to those. There is this option within Route 53 in AWS to use a service called a DNS alias. And all that is a reference to a service without using the underlying DNS name. So you're not using the IP address or the DNS record, but it's called an alias. And I'll connect the dots here in a second on that. And the last point I want to introduce on this is health check. So whether it's in this screenshot here, the Route 53 health check to multiple regions, if a region goes down, it can take out that entire region at your DNS level and route the traffic to the healthy region. So that can be very handy for your application if you need to be a global application. But that concept also applies to the next level down in the load balancer. You have health checks at that level too for your applications. And further on down, you'll have an equivalent for your database server and so on and so forth. So you can see how this gets very complicated in terms of keeping these dots connected of the DNS entries. So let's try to help with the headache that you may not have unless you have an outage. So what happens when you have a server failover? So let's say you have a database server and a replica ready to go in your new infrastructure. If the primary server becomes unhealthy, AWS will point the DNS record to the new server. That's great. Everything seems fine, except the fact that Java defaults to caching your DNS entries forever. You actually have to make a setting to override that. So they call that the time to live, and it's a value in seconds. And I provide on the screen an example of how to set that. You have two options. You can set your JVM arguments, or you can set it in the Java security file. I recommend you putting in your JVM arguments because that will retain, that value setting will be retained as you upgrade your JRE. But since the java.security file is within your JRE folder, anytime you update your JRE, you have to make sure to update that Java security file again. So I recommend putting that in your JVM arguments. Now, the other thing I want to throw out there, you may be struggling to figure out how to make this setting for the apex of your domain. So the apex of your domain is your domain name without any subdomain. So www.coldfsolutions.com, www is a subdomain. coldfsolutions.com by itself is called the apex. The DNS structure that is not anybody's fault. That's the way it requires you to use an explicit IP address for the apex of your domain. So how do you set up your apex if you have nothing but other DNS values. You don't have an IP address in AWS for your load balancer or your CloudFront or many other services. So this is where these into play. So you can set up your domain alias, your domain apex to point to the alias of the load balancer, if that's what you want. And that way your apex of your domain can actually resolve to a variable backend IP address. So that's a great little feature to have if you want to use your domain apex for hosting whatever service within AWS. The next thing I want to talk about is logs. You want to centralize all of your logs as much as possible. And, we had a great picture here of, what we like to do with our logs. We get a little happy face, put everything together and make it work great. But to do that with what tools are provided to you in AWS is this list here. You've got CloudWatch. I'm about to go into soon what CloudWatch is, but you can push all of your logs for ColdFusion, your operating system, and any custom logs you create from your application. You can push it into CloudWatch. So if you have 20 servers and they're all working great and one goes out, you push it to CloudWatch, you can have access to all of them regardless of the server availability. It also becomes protected because you cannot change CloudWatch after it's been created. Those log files become static. CloudTrail, you need to learn about CloudTrail. That's the log for your console activity. So any server change, reboot, any SDK access, CLI access, all that's logged in CloudTrail. So you need to know that that's available for inspecting any of your AWS auditing requirements. And last, I recommend you find a third-party log metrics aggregation service because CloudWatch is great, but it doesn't have all the tools out of the box ready to go for you. It's kind of like a blank slate that you have to then put together and piece all the pieces together to make it work for you. Whereas a third-party service like Splunk, Datadog, New Relic, Prometheus, those are built around providing visibility into your application servers and infrastructure in general. And I'm going to very briefly talk to you about what CloudWatch is. CloudWatch is a place where you can see all metrics for your AWS cloud environments. This can be CPU, network utilization, network timeouts. So if you have a HTTP request, it'll keep track of all the various things of your application environment. You have your CloudWatch logs are pushed into here. You can create alarms for both metrics and logs. So if your server gets unhealthy when it reaches 80%, you can set an alarm on that to trigger other actions. And last, you have events. You can set up events like a cron job. You can set up a scheduled task to kick off an SNS action on a schedule. All of that is within CloudWatch. So CloudWatch is your friend for keeping up with what your AWS environment is doing. So with your ability to see the metrics and see your logs, it's important that you need to right size. This is something that's more of a delayed issue for people. After you move to AWS, the last thing you want to have is a poor user experience. And you don't know that unless you keep track of things or if you're using your own application. This is where after you've migrated or before you've migrated, before you migrate, you analyze your metrics to make sure you're giving a consistent experience or better from your on-premise environment to your cloud. And that'll include your application metrics, your database metrics, your HTTP access logs, and the response times accordingly. And that's something that you have to understand based on what makes sense for your application. So let's keep your instances secure. And how do we do that? You can use a hardened server out of the gate. to reduce your attack surface. Make sure you keep your servers patched with the latest patches. Install an intrusion detection or intrusion prevention agent on your server. One thing I love to install on our servers are file integrity monitoring. So if you install a file integrity monitoring on your ColdFusion application server and the actual web content, the application content, you can keep an eye on when code is changed. So there's no surprises. If some reason your application suddenly has a new code out there that you didn't push, that's what file integrity monitoring is for. And because you listened to us earlier and you pushed your logs up to CloudWatch, even if somebody did change the logs local on the machine, you've caught it centrally. So there's nothing that can be spoofed in this situation. You can use a tool like AWS Inspector. You can scan your server for configuration issues or any CVE vulnerabilities that are for products installed on the server. And last on this list, utilize a WAF, a web application firewall. So all web traffic that communicates with your application server gets scanned, looks for common issues, SQL Server, SQL injection, so on and so forth. All right, a very common mistake of people moving to the cloud is not keeping their credentials secure. There's two tools that you should use or can use for making this easier for you. The AWS System Store Parameter Store and the AWS Secrets Manager. And for both of these, I recommend on your application start or the server start or whatever you need, you can go fetch and pull down these parameters or these secrets. And Parameter Store, you can encrypt. Secrets Manager out of the gate is encrypted. Secrets Manager has a little bit extra functionality, like it can be attached to a managed database server. So if your database server auto rotates its password, the Secrets Manager can be automatically updated. So any of your servers that utilize the database can get the password immediately from the Secrets Manager as needed. All right, so should be obvious. Next step here is to keep your network secure. Make sure you only explicitly allow network traffic that you expect for your appropriate application. You can do that with security groups. That is the mechanism that AWS uses for their network-based firewall. Another thing you can do is structure your subnets to a well-defined internal versus DMZ grouping. This just means you utilize the route tables to only allow the DMZ, demilitarized zone, the public subnets, to communicate to the internet, whereas the internal subnets do not. When you do that, you have to work out having a NAT gateway to route to the internet, but there is no direct internet traffic coming into your servers without traversing another path. And I'm sure many of you have worked with enough network issues that you can't connect to a box, the box can't connect outbound, or a variety of things. Try out the new reachability analyzer, new in the last year, I believe, that AWS provides. So you can choose two instances and say, hey, they're trying to talk via HTTP. Take a look at it. The reachability analyzer will hopefully find the connectivity issue that you have between those two instances. It's a really neat tool. I suggest take a look at it because at some point you're going to get to a point where two things aren't talking properly and you won't have a clue what's going on. And it could be 500 different things and you don't know where to start. And so last on this list, keep your network secure. Only use encrypted traffic transmissions where possible. So use HTTPS, use SSH, so on and so forth. Don't use the clear text communications. And speaking of that, how do we make our lives easier for this? So instead of purchasing an SSL certificate, downloading it, installing it, and deploying it to all the application servers you have, there's a product you can use called AWS Certificate Manager. So let's get rid of the headache of managing certificates with this. So in this case, if you have a set of servers behind a load balancer, you can attach your certificate from the certificate manager to the load balancer, and you can host your public domain that way. You can also use that for CloudFront, but in either case, this gets rid of the ongoing maintenance of managing your SSL certificates. So it will automatically deploy new versions of the certificate as the certificate expires. It also has, in the middle of all this, the load balancer is great for managing your compliance needs for what ciphers and level of encryption is required. So if your application requires TLS 1.2 and above, it's a very easy drop-down box to make that settings change. So that's something as well that becomes very convenient with this situation. All right, and this is the last one. We're going to keep your cloud environment secure. So probably the worst headache you can have is having your cloud console compromised. And there's a number of things to help you with this. And I'm just going to run through these very quickly. A lot of this is just to insert ideas in your head. So from configuration, you'll use something like Control Tower to automatically and consistently configure your accounts and manage your consolidated logs, your CloudTrail settings, all the things we spoke about previously. Control Tower can help you manage that right out of the gate. And something to consider in general as you configure your environments, separate your production environment from everything else. So don't mix your production environment with your development or testing so that you don't have as much traffic in terms of making changes to your production unless it actually is production specific. And the next thing on this is Guard Duty. So Guard Duty is a product provided by AWS that's great for monitoring your CloudTrail. It will help look for irregular activity in your account. It's very, I'm very impressed by this product, but it will alert to you something that is out of the ordinary for you. And it will look at CloudTrail, and it will look at the activity that has happened over time and makes a very, very useful alerts for you if something doesn't look ordinary. All right, identity and access management always require multi-factor authentication, whether it's a USB token, MFA, software MFA, whatever it is, require it, especially for any administrative account. You have your assumed roles. If you have multiple accounts, don't have a distinct login to each of them. Assume role into each account so that there's only one central point of authentication. And that way, it's a lot easier to monitor a sub account having authentication alarms go off if it's not the one that you're supposed to be using. You know immediately that this is a problem. You can focus on it more appropriately. Another thing you should probably do is rotate your IAM keys. So if you have a command line set up with static IAM keys, it's good to rotate those periodically, especially those of administrative rights, right access. You can probably tie that with your SSM parameter store to store those encrypted in each environment, and you can fetch them on launch. So if you rotate them, relaunch all the servers, and they'll automatically be provisioned across.
Recording stopped.
And the last thing I want to say here is data security. Encrypt anything you can with KMS if you want to keep things locked down. So if you expose some data and it's now been out there, if you don't share the ability to encrypt or decrypt with KMS, then that data is basically useless. So having read access is different than having read access with KMS authority. And having these segments can help you keep your important data safe. So with that, that's my presentation. I would like to do a Q&A. I'm not sure how to do that. Is there anybody, if you have any questions, I think you can chat and we will see if we can answer your questions. If there are none, thank you for your time. Appreciate you listening to our session today. And good luck with your migration and cloud development. Well, if you don't have any questions for me, feel free to reach out to us. An email address you can use is cf@colasolutions.com, and we'll be happy to respond. But it looks like we don't have any questions. Thank you, everybody. I appreciate your time. Have a good rest of your day.